Hello, this is the lecture number 1 for the chapter 3-dimensional geometry for the class 12th. Today we'll do the basics for the 3D which you have also done in your class 11th also. Now in 3-dimensional geometry, let us take, we have a room. It is a 3-dimensional solid figure in which we have three axes which are mutually perpendicular to each other. So let us take those three axes be this. I've taken these three axes as x-axis, y-axis and z-axis. They are mutually perpendicular to each other, means x-axis is perpendicular to y-axis, y-axis is perpendicular to z-axis and z-axis is perpendicular to x-axis. So these are three axes which are mutually perpendicular to each other. Suppose we have this three axes, x-axis, y-axis and z-axis. So this is the origin and they are mutually perpendicular to each other. We see it very carefully, a corner of a room. You will see that the three walls are mutually perpendicular to each other. Now, if you take any point in the space, let us take this the point x, y, z in any point in the space. This is what this x denotes. X denotes the distance of this point from the yz plane. So how can you denote that it is from the yz plane? Let us take these perpendicular to all the three axes. Perpendicular to all the three axes. Now x is the distance from the yz plane. So what is the yz plane? We have this is yz plane. So this is the distance of this point from the yz plane. This is known as the x. Y is the distance from the xz plane. So xz plane is this. So this is the y coordinate, this distance, and this z is the coordinate distance from the xy plane. This is the coordinate z. Now this xoy is known as the xy plane, zox, this plane is known as the xz plane, and zoy it is known as the zy plane. So x is the distance from the yz plane. X coordinate is distance from yz plane, and y is the distance from xz plane, and similarly z is the distance from xy plane. So you know the plane from this diagram: OX, OY, OZ axis. XOY is the XOY plane, this niche wala this, and ZOX, this is the XOZ plane, and ZOY is this ZY plane. Any point on the x-axis is taken as if you take any point on the x-axis, its coordinate will be x 0 0, that is y, and z coordinate is 0. If you take any point on the y-axis, it will be 0 y 0, that is x and z coordinate will be 0, and any point on the z-axis is taken as x 0 0 z, that is on the x-axis, x and y coordinate is 0. Similarly in OXY plane, in xy plane the value of z will be equal to 0. Similarly on ZY plane, the value of x will be 0, and on XZ plane the value of y will be equal to 0. So this is the basics for the three-dimensional geometry, or basics you have done in class 11th. How we take the point on the axis, how we take the point on the plane, and what this x denotes, what this y denotes, and what this x denotes. You have done the distance formula, the section formula in the three-dimensional geometry. Now after that we have direction of cosines. You have done in the vectors also, direction of cosine. Now direction cosines are the cosine of the angle made by the vector with x-axis, y-axis, z-axis. Suppose OP is the vector, it is making angle of alpha with the x-axis, beta with the y-axis, and gamma angle with the z-axis, and these are denoted by L, m and n. You have done in the vectors also. It is cos alpha, cosine of the angle made by the vector with the x-axis, y-axis and z-axis. That is cos beta and cos gamma. So these are the direction of cosines of the vector OP making an angle of alpha, beta, gamma with the alpha x-axis, y-axis and z-axis. Now after that we have direction ratios. Now direction ratio generally denoted by dRs and direction cosine is denoted by dCs. It is LMN and direction ratio is denoted by small abc's. Now these are the real numbers which make the direction cosines in the same ratio. ये वो real numbers होते हैं जो direction ratio को same ratio में ला देते हैं. L upon A, M upon B, N upon C, where L, M, N are the direction cosine and A, B, C are these direction ratios. They are equal to each other. Let us take it is equal to this. So L is equal to AK, M is equal to BK and N is equal to CK. And we know that you have done that L square plus M square plus N square is equal to 1. When you replace this value of L, M, N in this formula, you will get the value of K as 1 upon under root A square plus B square plus C square plus minus. So the value of K is this. So the K will be equal to, the value of K is 1 upon under root A square, B square, C square. So L will be equal to AK and the value of K is this. So when you replace the value of K here, you will get the values of LMN when the direction ratios are given. So when you solve it, you will get L as A upon under root A square plus B square plus C square plus minus M will be equal to plus minus B upon under root A square plus B square plus C square and N is equal to plus minus C upon under root A square plus B square plus C square. These are the direction cosines when the direction ratios of the line is given. Direction ratios of the line is given. Okay, so this is the direction cosines when the direction ratios are given. Now you have done that if the coordinate of any point points are given, let us say x1, y1, z1, and the coordinate of any other point is given as x2, y2, z2, then the direction ratios is x2 minus x1, y2 minus y1 and z2 minus z1. This you have done in the vectors also. So when the coordinate is given, first of all find the direction ratios ABC, x2 minus x1, y2 minus y1, z2 minus z1, and then you can easily find L, M and N, where L is equal to A upon under root A square plus B square plus C square, N is equal to B upon under root A square plus B square plus C square, and N is equal to C upon under root A square plus B square plus C square. So these are the direction ratios and direction cosines when the coordinates of the point is given. After that, you have to find the equations of the line in a space. Equation of a line in a space. Or let us first of all solve the exercise 11.1 first of all, which is based on direction ratios and direction cosines. So first is if a line make an angle of 90 degree with the x-axis, so we call it alpha. The angle made by the line with the y-axis is 135 degree. So beta will be equal to 135, and the angle made by the vector with the z-axis is we'll call it gamma. So it is given as 45. You have to find the direction cosine. So direction cosine is L cos alpha, M cos beta, N cos gamma. So cos alpha is 90. So L is equal to 0. Cos 135 angle. So 135 you can take 180 minus 45 minus cos 45, which is equal to minus 1 upon root 2, and N is equal to cos 45, which is equal to 1 upon root 2. So these are the direction cosines of the line which is making an angle of 90 degree, 135 degree and 45 degree with the x-axis, y-axis and z-axis. This is the question number 1 of your exercise 11.1. In question number 2, find the direction cosine of the line which make an equal angle with the coordinate angle axis. So let those equal angles be alpha, beta, gamma, be k, because they are making the equal angle with the coordinate axis. So L will be equal to cos alpha, which will be equal to cos k. Similarly, m will be equal to cos beta, and this is also m is equal to cos k, and n is equal to cos gamma, which is equal to n is equal to again cos k. Now because L square plus m square plus n square is equal to 1, so cos square k plus cos square k plus cos square k is equal to 1. 3 cos square k is equal to 1. So cos k is equal to 1 upon root 3 plus minus, and L is equal to m is equal to n. They all are equal to each other, and it is equal to plus minus 1 upon root 3. So it is the direction cosine when the line make an equal angle with the coordinate axis, that alpha, beta, gamma, they all are same. Now in question number 3, if the line has a direction ratios, so direction ratios आपको given है, we denote the direction ratios as ABC. So it is given as A as minus 18, B as 12, and C as minus 4. You have to find the direction cosine. So we know that when the direction ratios are given, the direction cosines are L is equal to A upon under root A square plus B square plus C square, and M is equal to B upon under root A square plus B square plus C square, and N is equal to C upon under root A square plus B square plus C square. So these are the formulae to find the direction cosines when the direction ratios are given, where A, B, C are given. So you can easily find the L, M and N. You can do the calculation yourself. Now in question number 4, you have to show that these 3 points are collinear. So this type of question you have done in the vectors also, and the easiest way to prove that these are collinear if the direction ratio of their direction ratios are equal. So first of all, find direction ratio of AB. So it is equal to, let us call it A1, B1 and C1, which is equal to x2 minus x1 minus 3, y2 minus y1 minus 5, z2 minus z1 minus 3. Then find the direction ratio of BC. Let us call it A2, B2 and C2. x2 minus x1, that is 6, y2 minus y1, that is 10, z2 minus z1, that is 6. Now if you see it very carefully, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. They all are equal to minus half, minus half, minus half. So therefore we can say that ABC are collinear, because one point B is common to this vector AB and BC line. So if you have to prove that the points are collinear, you prove that the direction of AB and direction ratio of BC are equal. So we can say that ABC are collinear. हम इसको collinear कह सकते हैं. Now after that we have question number 5. In question number 5, what you have to do, we have to find the direction cosines of the sides of the triangles. Direction cosines of the sides of the triangle. So the coordinate of A is given as 3, 5 and minus 4. The coordinate of B is given as minus 1, 1 and 2. The coordinate of C is given as minus 5, minus 5, minus 2. So you have to solve this 3 times, because first of all you find the direction ratio of AB, because you have to find the direction cosines of all the 3 sides. So first of all find the direction ratio of AB. So let us call it A1, B1 and C1. x2 minus x1, that is minus 4, y2 minus y1, it is equal to y2 minus y1, it is equal to 1 minus 5, that is minus 4, z2 minus z1, that is equal to 6. Now you can easily find the direction cosines of AB. Let us call it L1, M1 and N1. It is equal to A upon under root A square plus B square plus C square, that is A1, B1, C1, इस तरह से. Similarly, M1 direction ratio of AB, B1 upon under root A square b square, c square मतलब 1 ही आएगा, and similarly m is equal to c upon under root a square plus b square plus c square, where 1 1 1 c1. So like this we have to find out the value of direction cosines of AB, that is minus 4 upon under root a square plus b square plus c square. इस तरह से आप सारे AB के डायरेक्शन रेशोज एंड डायरेक्शन कोसाइन फाइंड कर सकते हैं. Similarly, you have to find the direction cosines of BC. So first of all, find the direction ratio of BC. Similarly, x2 minus x1, y2 minus y1, z2 minus z1. Let us call it A2, B2, C2. And their direction cosine, let us call it L2, M2 and N2. Similarly, find the direction ratio of AC. Let x2 minus x1, y2 minus y1, z2 minus z1. Let us call it A3, B3 and C3. And their direction cosine, call it L3, M3 and N3. So like this, you can easily find the direction ratios and direction cosines when the coordinates of any 2 points is given. Okay, we'll continue in the next lecture. Thank you.